Welcome to Inside Insights, your quick hit of tips, tools, and trends for manufacturing, distribution, and Dynamics 365 Business Central, brought to you by InsightWorks.
Right now, U.S. manufacturing is losing something like $50 billion a year to unplanned downtime.
It's a staggering number, yeah.
I mean, every single hour a critical line sits idle, it costs your average large manufacturing operation roughly $260,000.
Yeah.
And, the craziest part about those numbers, the multi-million-dollar software running these very factories is completely blind to the fact that the machines are dying.
It is a massive blind spot.
Yeah.
I mean, we're looking at Dynamics 365 Business Central today, and natively, the equipment inside that platform just has no voice.
Right. It's totally silent.
Exactly. You might have a critical bearing running incredibly hot, or like a major work center quietly ticking past its 1,000-hour service interval.
Or a fleet vehicle blowing 3,000 miles past its oil chain.
Right. The machinery knows it's hurting, obviously, but the system running the business is just completely unaware.
Okay, let's unpack this for you. I want you to imagine you're driving down the highway at 70 miles an hour, but the dashboard of your car is completely blacked out.
Oh, that's a good way to put it.
Right, like no speedometer, no check engine light, no temperature gauge. The absolute only way you know your engine needs oil is when it literally bursts into flames on the interstate.
It's terrifying.
But that is exactly how most ERP systems treat millions of dollars worth of heavy machinery.
It's a highly accurate, if terrifying way to visualize it. Though we should probably clarify that this is rarely a lack of willingness from the maintenance teams themselves.
Oh, sure, yeah.
Like those skilled millwrights and technicians, they desperately want to do proactive maintenance.
Of course they do. Nobody wants the machine to catch fire.
Right. What we're dealing with here is a fundamental structural disconnect between production data, what the machine is actually doing on the floor, and the maintenance activities required to keep it alive.
So the software handles the business of making things.
But it leaves the care of the machines entirely up to human memory.
Wait, I need to understand how we got here. These companies are spending absolute fortunes on cutting-edge platforms, right?
Oh, massive amounts of money, yes.
Yeah, they're tracking every single penny in the ledger, routing global shipments, optimizing inventory down to the specific shelf bin.
Yeah, the precision is incredible.
But they are still using a paper binder to track when a $1 million stamping press needs an oil change.
Natively, yes. That is the actual reality on the shop floor.
Wow.
And it sounds like a massive oversight until you look at the architecture. I mean, this isn't a flaw in Business Central. It's a very deliberate scope decision by the developers.
A scope decision? How so?
Think about the mindset of an enterprise software architect. The platform is brilliantly built to manage linear flows. Raw materials in, production steps executed, finished goods out.
Right, very logical. Step A to step B.
Exactly. But maintenance is entropy. It is the degradation of the tools making the goods.
Oh, yeah.
Because that doesn't fit the linear flow. The system essentially treats maintenance as something called a capacity absence.
Meaning the system just knows the machine isn't available to make things today.
Right.
It doesn't actually care why it's unavailable.
That is the core of the issue right there. Natively, you can go into the system, register a work center as unavailable, maybe block off some time on a calendar.
Just block it off like a meeting.
Yeah, exactly. And maybe you bury a text note in a comment field somewhere.
Right.
What you cannot do is define a recurring inspection interval based on actual usage. You cannot track runtime against a machine center.
You can't even store a native list of spare parts, right?
No, not for a specific asset. And you certainly can't hand a technician a mobile device with step-by-step digital work instructions.
Which totally explains the paper binders. I mean, the maintenance team has no choice but to build their own silo because the main platform just shut them out.
Yep. They retreat to whiteboards, spreadsheets, physical binders, or maybe, completely standalone software programs that never even talk to the main ERP.
Just to keep the factory running.
Exactly. And to give you the bigger picture, people often point out that Business Central has a fixed asset register.
Right, right.
And they ask, well, why isn't that used for maintenance?
Because it's an asset, right. It makes sense on paper.
It exists, sure, but it's designed for accountants. It records the existence of your equipment so you can track its financial depreciation over time.
So it's just about the money.
Completely.
Yeah.
It provides zero native mechanism to trigger a work order when a machine hits, say, 500 hours of runtime.
Okay, so the accountant knows exactly how much the machine is worth on paper as it depreciates.
Yes.
But the operator running the machine has no idea the internal components are literally grinding to dust.
That's a perfect summary of the disconnect.
I mean, natively, that is a glaring gap. But surely companies haven't just accepted the blacked-out dashboard forever. People must be finding ways to bridge that gap.
Oh, they try. The traditional approach was to go out and buy a completely separate system, like an EAM platform.
Enterprise asset management?
Right. You purchase this entirely separate software specifically built for maintenance, and then you attempt to bolt it onto your ERP.
And let me guess. Bolting two massive software platforms together never works as smoothly as the sales brochure promises.
Not even close. The integration burden is massive.
I can imagine.
You pay for extra licensing, you battle constant data syncing errors.
The APIs break every time there's an update.
Constantly. And you force your technicians to climb this steep learning curve to use a completely different interface that looks nothing like the rest of the company's software.
Okay, so here's where it gets really interesting. Because looking at the specs for a maintenance manager by InsightWorks, they approach this entirely differently.
Very differently, yes.
If the old way of bolting on an EAM was like hiring a clunky translator who only half understands both languages.
Right. Constantly dropping words and causing confusion.
Exactly. Maintenance manager just teaches the ERP a new dialect based on words it already knows fluently.
That's a great way to frame it.
It's like instead of building a fragile bridge between two separate islands, the EAM island and the ERP island maintenance manager just builds a new house right on the mainland.
Yep. It's a CMMS that runs natively inside Business Central.
Natively.
That word natively is critical here. It represents a real architectural breakthrough.
Because they aren't faking an integration.
Right. They didn't just build a parallel data structure inside the platform and cross their fingers hoping it synced up. They made one brilliantly simple design choice.
Which is?
Maintenance Manager uses standard Business Central production orders as the foundation for its maintenance work orders.
Okay, I get why native is better than bolted on, but I don't quite get the mechanics there.
Sure.
If Business Central wasn't built for maintenance, aren't they just forcing a square peg into a round hole by calling a maintenance job a production order?
It sounds like it, but think about the ripple effects of what a production order actually does. It's a language Business Central is already a master of.
Right, it does production very well.
Exactly. The platform knows how to pull parts for a production order. It knows how to schedule time for one and how to track the costs associated with it.
Oh, I see where this is going.
By disguising a maintenance job as a production order, suddenly every single existing capability in the system works perfectly with maintenance, right out of the box.
Meaning you don't have to write custom code to tell the warehouse how to pick a spare part?
Nope.
The warehouse already knows how to pick parts for production, so it just does its normal job?
Precisely. Warehouse functions, shop floor execution, planning worksheets.
Oh, it just flows.
Even third-party ISV apps created by independent software vendors. They all instantly know how to interact with these maintenance orders because, to the system's core architecture, it just looks like another standard process.
That is incredibly elegant. Hacking the system using its own rules, basically.
It really is.
And because of this design, the setup is supposedly shockingly simple. Like, there's an installation wizard that applies default data and posting groups.
Yeah, making it usable almost immediately, which is unheard of for maintenance software.
And I assume you don't even need that fixed asset record we talked about.
Right, it solves that major headache, too. With this native solution, you don't even need a fixed asset record to track an item.
So you can track smaller stuff.
Exactly. You can set up equipment as standard items with a maintenance designation that allows you to track maintenance on smaller tooling, fleet vehicles.
Things that don't financially qualify as depreciating assets but still need oil changes?
Absolutely. Things that require regular maintenance to keep the business running.
Okay, so the foundation is laid. The system understands the language. But a platform doesn't magically know a bearing is wearing out.
Right.
Something has to feed it data. How does the system actually track the wear and tear without relying on someone typing numbers into a keyboard all day?
Well, we have to look at how we measure degradation. Maintenance Manager allows you to set intervals in 4 distinct ways.
Okay.
The first is simple duration. Weekly, monthly, annual.
The classic calendar method. Like change the oil every 6 months whether the machine ran for 5 hours or 5,000.
Yeah, it's a staple, but it's highly inefficient. The next 3 methods are where the real power lies.
Let's hear them.
You can trigger by runtime, say every 500 machine hours. You can trigger by output count, like every 100,000 cycles or pieces produced.
Or distance for vehicles, right?
Exactly. Every 10,000 miles for a fleet vehicle.
But how is it getting that data? Because if a shift supervisor has to walk around at 5 o'clock every day with a clipboard,
Great.
reading gauges, and manually typing the runtime hours for 40 different machines into the system, we are right back to massive human error.
That's the best part. It eliminates the clipboard entirely.
Yeah.
Because this is a native solution, production assets are already linked to work centers.
Right.
The runtime and output counts update automatically whenever a production order posts against that specific resource.
Wait, really? So the machine finishes a batch of parts, the operator logs that the batch has done.
And the system just quietly ticks up the wear and tear counter in the background.
Yes.
Zero manual data entry required. The production log and the maintenance log are essentially reading from the exact same source of truth.
That is huge.
The margin of human error vanishes because the machine's actual output is directly driving its maintenance schedule.
Okay, let's follow that logic. The machine hits 100,000 cycles and automatically flags that it needs a new bearing. The dashboard finally lights up.
Right.
But a flag in the software doesn't physically fix the machine. If the parts cage is empty, all that beautiful data is useless.
So true.
So what does this all mean for the person whose job it is to order the parts? Are we finally eliminating the panic of realizing a part is out of stock on the day the machine breaks?
Historically, this is where silos cause the most financial damage.
Oh, for sure.
The maintenance team would know they needed a specialized part, but the purchasing team wouldn't find out until a work order was slapped on their desk.
We need this tomorrow.
Exactly. With Maintenance Manager, when that interval is triggered, the system generates a work order that includes a complete BOM, a bill of materials for the required spare parts.
And the labor routing too, right?
Along with the specific labor routing, yes.
So it basically builds a recipe. It lists exactly which physical parts are needed and what kind of mechanic is required to install them.
And because it exists natively within the ERP, those required parts instantly become live demand signals.
Oh, wow. The purchasing system sees the demand coming before the machine is even taken offline?
Exactly. The standard automated planning run, the process that constantly analyzes what the company needs to buy to fulfill its orders, it reads that maintenance order.
Just like any other order.
Right. If you do not have enough of those specific bearings in stock, the system will automatically recommend purchasing them.
Which gives you plenty of lead time.
Often weeks in advance of the scheduled maintenance date.
That completely eliminates the panic buying. Ordering the parts before the machine breaks, based on mathematical reality rather than a supervisor's gut feeling.
And consider the impact on production scheduling as well.
Right, the downtime.
When that work order is released, the maintenance capacity is officially consumed in the master schedule. If a facility runs an automated production scheduling tool, that tool sees the maintenance window.
So it doesn't double book the machine.
It actively routes production around it. It finds the least disruptive time slot to take the machine offline automatically.
That avoids the catastrophic scenario when you are forced to break down a machine in the middle of a rush order.
Which leads to missed customer deadlines, expedited freight costs.
Massive operator overtime.
Exactly. Treating the maintenance of the machine with the exact same respect and priority it treats a paying customer's order.
Because financially speaking, ignoring the maintenance costs just as much, if not more, than losing a customer's order.
It really does.
So we have the parts sitting on the shelf. The schedule has been automatically adjusted to avoid interrupting critical production runs.
Everything is lined up.
Now we have to talk about the shop floor itself. What happens when the actual wrench needs to turn? Because ultimately, software doesn't fix machines, people do.
That's a great point. The human element dictates the success of the entire implementation.
If it's too hard to use, they won't use it.
Exactly. If the software is too cumbersome to use on the floor, technicians will bypass it, and your perfect loop of data is broken instantly.
So how does it handle the execution?
On the execution side, technicians do not need a desk or a workstation. They access their work orders directly via the Business Central mobile interface.
Right, on a tablet or phone.
Or through a shared shop floor terminal.
It is essentially giving them the ultimate, fully digitized mechanics clipboard that talks directly to the boardroom.
It's exactly what it is. When they pull up the job, they aren't just seeing a vague title like fix conveyor.
Right, they see detailed work instructions.
They have the actual equipment manuals attached, sourced directly from the document management system. They see the exact component requirements right there on the screen.
No more walking back and forth across a massive factory floor for 20 minutes just to find the physical manual for a specific belt drive.
Time on task is optimized. And just like a production operator captures their time, the maintenance technician clocks on and off the job directly in the interface.
Just tapping a button.
Yes. This captures the actual real-world labor time against the maintenance order.
Meaning the CFO finally knows exactly how much it costs in raw labor to maintain that specific piece of equipment over its lifespan.
The visibility changes everything. And for the supervisors managing these teams, the value of eliminating tool switching is immense.
Tool switching, you mean software tools?
Right. They gain a maintenance calendar with a drag-and-drop view of scheduled work. More importantly, they have a single graphical scheduler that displays maintenance orders right alongside production orders.
In one unified capacity view.
Yeah.
So they see the full picture on one screen. No guessing, no toggling between two completely different software programs trying to mentally cross-reference schedules.
It makes their job so much easier. And for the Microsoft partners, too, the consultants who actually install and configure Business Central for these manufacturing clients.
Oh, I bet they love this.
This natively integrated approach is a massive relief. Most manufacturing and distribution clients feel this maintenance gap daily,
Sure, it's a huge pain point.
but they rarely articulate it as a solvable problem within their main platform. They just assume these ERP platforms don't do maintenance.
So historically, when a client asked for maintenance tracking, the partner would have to brace them for a massive, expensive custom integration project.
Exactly. But because Maintenance Manager runs natively and uses that brilliant production order infrastructure we discussed, the implementation conversation becomes incredibly straightforward.
Because there is no parallel system to build, no complex APIs constantly breaking every time Microsoft pushes a system update.
And the licensing model reflects that simplicity as well. It scales reasonably.
Even if it's a smaller team.
Even if a facility just has a single maintenance administrator managing a whole team of technicians on the floor, it does not price the company out of solving the problem.
That's fantastic. Looking back at the journey we've taken today, we started in a pretty dark place.
We did. A $50 billion dark place.
Right. We had factories running completely blind, bleeding $250,000 an hour to unplanned downtime.
Yeah.
We had massive, sophisticated software systems that basically shrugged their shoulders when it came to machine maintenance, forcing everyone back into the dark ages of paper binders, whiteboards, and drifting calendar estimates.
But the shift we've mapped out is moving from that reactive guesswork to a connected system driven by actual reality.
Actual data.
Triggering maintenance based on the exact cycles a machine is run. Seamlessly ordering parts weeks ahead of time.
Routing schedules intelligently.
Putting digital manuals right into the hands of the technicians.
Giving the equipment a voice, basically, but doing it in the exact dialect the rest of the business already speaks fluently.
Perfectly said.
For those of you listening, if you want to explore the mechanics of this further, or if you are sitting there realizing your own multi-million-dollar factory is running on a dusty paper binder, you really need to check this out.
The full product details, feature overviews, and a 30-day trial are available at maintenancefordynamics.com.
And you should definitely reach out to a certified Microsoft partner who can walk you through a hands-on demo to see it actually running in your own Business Central environment.
Seeing those maintenance triggers mapped directly to your specific production routing is usually the moment the concept fully clicks for facility managers.
It makes it real. Before we wrap up this deep dive, though, I want to leave you with a thought to mull over. Something that builds on all these facts, but looks just a bit further down the road.
Okay.
We've established that this native integration now tracks the exact runtime, the precise maintenance costs, the spare parts consumed, and the actual labor hours required to keep every specific machine alive.
Right. The total cost of ownership is no longer an estimate. It becomes undeniable mathematical fact.
So here is the question. If executives finally have this proven data living right inside their financial system, how will this shift the way they decide which manufacturing equipment brands to purchase in the future?
Oh, that's a fascinating angle.
Right. If brand X machines cost 3 times as much in labor and parts to maintain over 5 years as brand Y, but you never knew it because the data was hidden away in a siloed spreadsheet. Well, you know it now.
Good data doesn't lie.
When your equipment finally gets a voice and that dashboard lights up for the very first time, what secrets is it going to tell you about your past investments? Let that sink in. We will catch you on the next Deep Dive.